Today we're going to be looking at the area of trapezoids, rhombuses, and kites. So for the area of a trapezoid, it's 1/2 times the height. And remember, the height, just like in our parallelograms and in our triangles, it's the perpendicular distance between the bases. So that perpendicular distance between our bases. So let's look at our first example. It says find the area. So the area is 1/2 times the height with the sum of our bases. So we know our height as the perpendicular distance from the two bases. So our height is 12.8. And our bases, we have the bottom base is 30.8. And our top base is 20.8. So if we add those together, we can get the area equals 1/2 times by 12.8. When we add those two, we get 51.6. So now we can multiply those out, and we get that the area is 330.24. Still working with the area, so it's inches squared. So base, and our height. So let's look at another problem. Still working with a trapezoid, so it's going to be area equals 1/2 times the height times by our bases added together. So here we have two bases. Our height is the perpendicular distance from our two bases, and we don't know what that is. So we actually need to find it. So if we take a look, we're given that this is 30 degrees. If we take that line, which is still that x, we don't know what that height is. We know this side is 9, so we know this chunk from here to here is also 9 units. So if the whole thing is 25, we know this section from here to here has to be 16, because 16 plus 9 is 25. So since we know that this is 16 and this is x, we're going to be using tangent of 30. We're using tangent of 30 because this is our opposite side and this is our adjacent. So tangent of 30 equals the opposite, x on top, 16 on the bottom. So when we multiply those, the tangent of 30 times by 16, we get 9.24 equals x. So that means our height is 9.24. So now we can finish the problem. Area equals 1/2 times by our height, and our two bases added together, so 25 plus 9. So these three. So area equals 1/2 times 9.25. 25 plus 9 is 34. So when we multiply these together, we get 157/800 units squared, and it's units because we're not given a specific. Alright, let's look at this one down here. We need to find the area of this shape. Right now this shape isn't anything we've worked with, but if we take and split this down this line, we end up with two trapezoids. So if we look at both of these trapezoids, I'm going to first cover up this one so we can figure out bases and heights. So let's find, these are going to be our two bases, because those are the two lines that are parallel. So the height, we're here at 1 and we're going up to 6, so this has a height of 5. If we're at 1 here and we're going all the way up to 10, this has a height of 9, or sorry, a base of 9 and a base of 5. So then our height is that perpendicular line between our bases. So that height is going to be from 1 to 6, which is 5. So now let's find the area of this trapezoid. So we have the area equals 1/2 times by our height, which is 5. And then we have 5 plus 9. So area equals 1/2 times by 5. 5 plus 9, we get 14. So if we do 1/2 times by 5 times by 14, we get the area is going to be 35 units squared. So now let's take a look at the other side. So we already know this base, which is 9. So then this base over here still starts at 1, goes up to 9, so that has a base of 8. And here we have that it's going to be 1, 2, 3, height of 3. So we have area equals 1/2. Our height is 3. Our bases are 9 plus 8. So area equals 1/2 times 3. 9 plus 8 is 17. So our area is going to be 25.5 units squared. So we want to find the area for this whole figure. So in order to find the area of the whole figure, we want to add them together. So when we add these two, we end up with 60.5 units squared. Let's look at rhombuses and kites. So when we take a look at these, the area formula is 1/2 times the diagonal 1 times the diagonal 2. So for this first one, we need to find the area of the rhombus. We need to know the lengths of both of our diagonals. So this diagonal is 9 plus 9, so we know it's going to be 18. And the second diagonal is 13.5 plus 13.5, which is 27. So when we multiply these out, we get 243 meters squared. Alright, so let's take a look at this rhombus. We are still working with the same formula, 1/2 times diagonal 1 times diagonal 2. We already know one diagonal, that is 16. So now we just have to find the second diagonal. So in order to do that, we know we are looking for this diagonal right here. We know this side length is 29. This side length has to be 8. So here we have a right triangle. And since we know it's a right triangle, we were missing a side, we can use the Pythagorean theorem. So we know we have 8 squared plus, we don't know what this length is, so I'm going to say x squared, and our hypotenuse is 29 squared. So we end up with 64 plus x squared equals 841. So if we subtract 64 to both sides, x squared equals 771, or 77. And if we square root both sides, x equals 27.9. So we know that part, that half of that diagonal, is going to be 27.9. So we also know that this is going to be 27.9. So that diagonal is 27.9 times by 2. So our missing diagonal is 55.8. So if we multiply that out, the area is going to equal 446.4 units squared. Last example. Find the area of the kite of ABCD if AC is 48, so this whole thing is 48. AB is 25, and BC is 26. So what we need is we need this one, so if we know that this is 48 and it's cut in half, so that means these two sides, this is 24 and this side is 24. So that means we get to do the Pythagorean theorem twice because we need to find this length and then this length. So we know our hypotenuse is 25, so we have 25 squared equals 24 squared plus x squared. So when we go to solve that out, we get 567 for the 24 squared equals 25 squared is 625. So when we subtract the 2, we get 58, and when we square root, 7.6. So this distance is 7.6. So now we have to find this length. So we know the hypotenuse in this case is 26. So we still have 24 squared. We don't know what the longest leg is, but the hypotenuse is 26. So we have 567 plus x squared. 26 squared is 676. So when we subtract those two, we end up with 109. When we square root, we get x equals 10.4. So that means this distance is 10.4. So to find the whole diagonal then, we have to add 7.6 and 10.4. So one diagonal is 48, and our other one is 18. So then when we multiply it out, 432 centimeters squared.